am sure all of you must have done the homework which I gave in the last session, and that was 3a 5b 7 is equal to p plus q, p is less than q, and p and q both are prime. What is p? What is q? We did a similar question in the last session. Let's recall that. Let's recall that. There I said one thing: all the prime numbers are odd except 2. All the prime numbers are odd except 2. So let's call it 2 for a second. Can I say p is odd, q is odd? The sum of two odds is even, but then this is odd. Therefore, both p and q are not odd. One of them has to be even. The only even prime which we know is 2, and that's fortunately the smallest prime also. Here p is less than q, therefore p has to be 2, and therefore q is 3a 5b 5. I hope this is clear to all. No, this is not yet over. Mind it, guys. Q is not prime. Let's think of something else. Can you think of any other even prime number? No. And therefore, I say the answer to this question is wrong. I gave you this question as a brain teaser so that you can think over it. I hope this is clear to all. Let's move on. Divisibility rules. Something very important which has been asked in fact quite a few times. Divisibility rule of 2, all of us know, is that the unit digit should be 0 or even. Fine. That of 3 is sum of the digits should be divisible by 3. That of 4 is last two digits in the order in which they are present in the number should be divisible by 4. Let me show you an example of what I am saying. 1, 2, 3, 4 if I talk of, if 34 is divisible by 4, this entire number is divisible by 4, or else it is not. Since 34 is not divisible by 4, I say 1, 2, 3, 4 is also not divisible by 4. 3, 4, 5, 6. Since 56 is divisible by 4, I say 3, 4, 5, 6 is also divisible by 4. Divisibility rule of 5, all of us know, is unit digit should be 0 or 5. Divisibility rule of 6 is number should be divisible by 2 and should also be divisible by 3. Mind it, I said 2 and 3. So it has to be divisible by both. Let's talk of something very interesting. Suppose there is a number which is given to us and we want to find out remainder after dividing it by 2. How should we be going about it then? I said just divide the unit digit and find out what is the remainder. Is the remainder when you divide the entire number by 2. Similarly, if there is a number we want to divide by 3 and want to find out the remainder, then divide the sum of the digits by 3. Whatever is the remainder by dividing the number also. So what I am saying in a way is divisibility rules can also be used to find the remainders. Let's see if it works in case of 4 or not. In this case, 8 4 is 32. Therefore, by dividing 34 by 4, I will be left with remainder 2. Therefore, the entire number when divided by 4 will give us the remainder of 2. Similarly, since this number is divisible by 4, 56, so the remainder in this case will be 0. In case of 5, divide the unit digit by 5. Whatever is the remainder by dividing the number by 5 otherwise also. In case of 6, let's see. That's quite interesting. So 6 is since 2 into 3. What will we do? We'll find out the remainder by dividing the given number by 2. Say that remainder is x. Similarly, we'll find out the remainder by dividing the given number by 3. Say that remainder is 5, y. Now, see the option which when divided by 2 leaves a remainder of x, when divided by 3 leaves a remainder of y. That is the right answer. Remind it, guys, there cannot be two such options which when divided by 2 leaves a remainder x, when divided by 3 leaves a remainder y and are less than 6 also. There will be only one such value, that will be the right answer. Or alternatively, you can think of a number less than 6, which when divided by 2 leaves a remainder of x, when divided by 3 leaves a remainder of y. That is the right answer. Wherever that is there in the options, you just need to pick that. Let's see the divisibility rule of 7. Say we have a small number. Start making triplets from the right hand side. Take the sum of the triplets at odd places and those at even places. Let's call it S1, let's call it S2. Mind it guys, one of the triplet was not complete, so I did a 0 or whatever number of zeros is required and then left. Now I am saying find the sum of the triplets, not the sum of the digits. So this will be 0, 1, 2 on one side, 3, 4, 5 on another, 6, 7, 8 on the first one, 9, 1, 0 on the second one, 1, 1, 1 on the first one, 2, 1, 3 on the second one. This is, and this is 8, 0, 1. We are supposed to do what now? We are supposed to find out S1 minus S2. If this is 0 or a multiple of 7, I will say the number is divisible by 7, else it is not. In this case, 1468 minus 801, which is 667, not divisible by 7. Therefore, the given number is not divisible by 7. If 667 would have been divisible by 7, the number would have been divisible by 7. I hope this is clear to all. Divisibility rule of 8 is very much like that of 4, that is, but slightly different. Last 3 digits of the number in the order in which they are present in the number should be divisible by 8. In case of 9, some of the digits should be divisible by 9. Divisibility rule of 10 is slightly difficult. You guys Google it. I don't know. Divisibility rule of 11 is difference of sum of the digits at even places and odd places should be 0 or a multiple of 11 for the number to be divisible by 11. Divisibility rule of 12. 12 is 2 into 6, or I can say 3 into 4. Whenever you are looking for divisibility rule of a composite number, guys, split it into co-prime factors. So 3 into 4 in this case will work. 2 and 6 are not co-prime, so if you use 2 and 6 for 12, that won't work. Once again, what are co-prime numbers? Any two numbers of which HCF is 1 are co-prime numbers. Now question for you. We have a number AAA, 6 times 8 is divisible by how many non-composite numbers? Choices are 5, 6, 7, 8. Think over it. Okay, my turn now. Can I write 6 times A in this fashion? 1, 1, 1, 1, 1, 1. So what is this? A into 1, 1, 1 into 1001. How have I written 111, 111 this way? That's up to you. I'm sure you can work on that. Now what is 1001? 7 into 11 into 13. So for sure 6 times A is divisible by 7, is divisible by 11, is divisible by 13. What is 111? 3 into 37. So I will say AAA is also divisible by 3 and 37. And mind it guys, AAA is also divisible by 8. So and also divisible by 1. So I can say that 6 times A is divisible by 7 different non-composite numbers, including 1 of course. The answer is 7. Had I known A, I would have probably find out a couple of more. That's it for today.